All right, hello. In today's video, we are going to be talking about two other transformations. So far, what you've learned about are reflections and you've learned about translations. Today, we're going to be talking about rotations and dilations. All right, so the first one we're going to talk about is a rotation. Now, to do a rotation, you basically need, all right, let's just address how weird my head looks with this light on my neck. Just pointing it out. Okay. The first one we're going to talk about is rotations. And to complete a rotation, you need three pieces of information. You need, first, a center point, a point of rotation. So that's kind of like when you're doing reflections, you need to know what you're reflecting it over. You needed to know your line of reflection. In a rotation, you need to know where your point is. So we'll call this point Q. That'll be our point of rotation. The other thing we need is a figure. So I have this very cute little red triangle, and I'm going to put it right here. I'm going to trace it so that it's nice and clear to see. Call that point A, B, and C. Now what a rotation does is it will take the shape and it will rotate it around that center of rotation. So the first piece of information you need is where's the center of rotation. The second piece of information you need is how many degrees is it going to be rotated. Is it going to be rotated 90, 180, or 360? Where will it end up? The third piece of information you need is the direction. Is it going to go clockwise or is it going to go counterclockwise? So when you're doing a rotation, the way I like to see the big picture is it can kind of form an orbit around the center point. So I'm going to go ahead and draw a circle here so you can see the full range of where that shape could be rotated. So it's not a perfect circle, but I tried my best. So basically, here's my shape. Here's my image. If somebody told me to rotate it counterclockwise, so opposite the way the clock goes, about 90 degrees, that would be going about that far. And then this would be where my image would land, because I just rotated it about 90 degrees around the center point Q counterclockwise. Someone could also say rotate it 90 degrees clockwise, and that means I would go different direction. Rather than going that way, I would go down over here. Now 90 degrees is about a quarter of a circle. So if someone told me turn 90 degrees, I could turn either to my right or I could turn to my left. I turned a quarter of a circle. If someone told me to turn around 180 degrees, that means I turn totally around. So on this, by totally around, I mean I face backwards. If I was rotating a figure 180 degrees, that means I'd go halfway around the circle. And that, if you'll notice, doesn't matter if they tell me to go clockwise or counterclockwise. If they told me to go clockwise 180, I go halfway around the circle that way. And if they told me...
Lauren Ryerson, please come to the front desk. Lauren Ryerson, please come to the front desk. Thank you.
All right, somebody just got dismissed. That was an announcement. If they told me to go 180 counterclockwise, I would go the other way, but I'd end up in the same spot because I'm just going halfway around the circle. And if someone told me to go 360, where do you think I'd go? Bum, 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 bum. Look at it go. Wow, there's the 180 mark, and all the way around back to where it started. 360 just means you end up where you started. Stop! The Eggersteds are in here and they're laughing at me. So that's what a rotation looks like. If you want to know a little bit more about how a rotation happens in detail, let's say someone asked me to rotate the figure 80 degrees. What I would do is I would take point A and let's say they told me rotate the figure 80 degrees counterclockwise around this point Q. Let me redraw my triangle here since it got wicked smudged. To rotate it 80 degrees, what I would do is I would draw a line from point A and then another line going off point Q to make an 80-degree angle. So that's where I would want to use the protractor. I want to take that point A and I want to make an 80-degree angle with the center point Q. All right, here's 80 degrees. No, wait, that's like 100. 80 would be a Q. It's right there. All right, and then my new point A would end up right there. That's where I prime would be. And then I would repeat that process for the other points. I would go from point B to the center point Q, make an 80-degree angle, do the same for point C. Go to center point Q, make an 80-degree angle. That's just to give you a visual representation and an idea of the process behind how a figure gets rotated. And that's all I'm going to tell you about rotations. Next, we are going to talk about dilations. So rotation, translation, and reflection, those were all examples of rigid transformations. Because no matter where I move that triangle, it is staying the same triangle. Side lengths are the same, the area is the same, nothing about it's that different except for its location. Now a dilation, that's when you start changing the properties of it. You start changing the side lengths and the area can change too. So let's try, I'm looking at my notes here. We're getting a very, greetings, nice zoom in on my face. Okay, let me scroll up over here. Okay, so I don't know if you can see the notes on the board there. I'll read them out. Dilations in the coordinate plane. So we just did a rotation kind of in blank space. Rotations can also happen on the coordinate plane. You'll learn more about that tomorrow with the applet. Let's talk about dilations on the coordinate plane now. So a dilation, we want to draw quadrilateral, that means 4 sides, JKLM with vertices -2. Wait, no, I'm sorry. I don't want to look at that one. I want to look at the next one. Here it is. Triangle XYZ has vertices X, 2, 2. So I'll go to 2, 2 on my graph. Y, 0, -2. Go to 0, -2. And Z, -2, +2. Okay. X, Y, Z. There's my triangle. Okay, good, you can see it. All right, and we're at 8 minutes, not 20. All right. Now I'm being asked to perform a dilation by 3 with the center of dilation at a point I didn't want to do it at. I wanted to do it at the origin. So I'm going to say how to do it at the origin, or I'm going to start a new problem. Sorry. Okay. Maybe I did. Whoops. Oh, I'm sorry. I did want the quadrilateral JKLM. I'm sorry. I misread my own little note here. Okay. So first thing I got to do is just read the coordinates for JKLM. It's J at -2, +4. I need to pull up my camera here. No, I clicked on the wrong thing. Okay. J -2, +4. K at -2, -2. And L at -4, -2. And M at -4, +2. Okay. So I have a quadrilateral here. It's got 4 sides. Okay? And I am being asked to graph the image after a dilation about the origin with a scale factor of 2. So you might hear different terms here. You might hear scale factor or dilation factor. That means the same thing. What that means with the dilation point at the origin, we'll learn about a dilation point not at the origin later on. For now, it's just going to be at the origin. That means take your coordinates and double them. So we started with J at -2, +4. Okay, so that means that I'm going to want to double it. So now J prime, the image point for J, is going to be -4, +8. Because I doubled, -2 times 2 is -4, +4 times 2 is +8. So J prime will be at -4 and +8. So J prime is up here now. Okay? And I'm going to continue that process for the other points. I'll try and use different colors. That way it's easier to see. Okay? K prime, or K originally, was at -2, -2. So K prime, I want to double the X coordinate. It'll be at -4, and double the Y coordinate. It will also be at -4. Okay, good. You can see that okay? All right. K -4, -4. I have that new segment of it. All right, I'll do the next point. I'm going to write over here. L was at -4, -2 originally. So L prime, I want to double it, will be at -8, -4. -8. You can start to see the shape forming here. We have that same right angle. So the shape will look the same. It'll just look like the size. The size is different. It may be smaller. It may be larger. If the dilation factor is bigger than 1, so like if it's 2 or 5, that means you're going to multiply the coordinates by that number, 2 or 5, which will make them, in turn, make the shape look bigger. When you end up with a dilation factor that's a fraction or a decimal, like 1/2 or 0.2, that means you'll multiply the coordinates by that number, and that will in turn make the shape look smaller. And again, you'll have the applet and practice in the next class, and that'll help solidify your knowledge. I'm not going to do the 4th point because I feel like you guys could do that on your own. The original point is M, -4, +2. See if you can figure out what M prime would be. All right, thank you for tuning in, and I hope you have a wonderful rest of your day. Bye. See you next class.